So in this problem, we're asked to go from benzene to this carboxylic acid molecule. So we're asked just to devise a synthesis that would help us achieve this reaction. So let's start with a little bit of retro, shall we? Let's draw out our starting materials. And instantly, I look at that carbonyl and I say, oh, I could probably do this through a CO2 reaction, right? If I want to make a carboxylic acid right there, I know that I could use CO2 and an acid workup step, of course, to give us this, if I were to use a Grignard here. So if I use MgBr, we know that this bond is very polar. It's going to attack that carbon, make a carboxylate, and then we're going to protonate it with H3O+. Okay, and that will give us that. So we have a good starting. How can we make a Grignard from here? Well, we know that we need a halide in that position. Right? We're going to react magnesium with, what's that called? Ether? Ethyl ether? Jeez Louise. Diethyl ether. Sorry, I'm not too good with the naming of ethers, but... And I should. They're quite easy, right? Anyways, so we have this, Grignard process, and then we go from a halide. Now, you could go two ways here, and I'll show you both. I think the way that I'm going to show is better. It's how the book presents it. The way that I went might be good, but, you know, maybe not so much. But the way that the book explains this problem is, okay, many syntheses can be correct, but whichever one leads fastest or is cheapest is usually the best. Right, so we have to use a more pricey reagent, NBS, for this. NBS under photochemical or heated conditions, okay? Not my personal favorite choice, but this will do. Benzylic bromination. It's going to install a bromine here by ripping off the hydrogen, putting a radical here, a resonance stabilized radical, and then that will couple with a bromine radical, come together, click, and you're going to get this, okay? But then how can we make this from benzene? And that's just simple Friedel-Crafts alkylation. So we start from this, and we're going to use AlCl3. And then remember, we're going to bond a chlorine-like thing to it, but we need to attach our alkyl group, so we do exactly that. So we use this. This attaches on, and then it will make a carbocation and deliver it to our benzene ring there. Okay? Quite simple. And again, then we go through NBS, make a Grignard, do a CO2 formation of a carboxylic acid. So that's the synthesis that the book says. I got from here to here, and I said, okay, we could do this a different way. Using more water kind of chemistry. So my thought process here was, okay, let's use an alcohol. Okay, because I know that from an alcohol, I can use a Grignard, right, on a ketone, right, to get this. All right, so we'll have a Grignard attack and then an acid workup, so this is H3O+. And a methyl Grignard, MgBr. Okay, so step 1, step 2. So write that Grignard attacks, gets protonated, and you get that. Okay, so then the step to get this, I said, okay, we could do Friedel-Crafts acylation from the benzene ring using AlCl3 and using ethanoyl chloride. So going from this to this, it's a little bit longer the way that I solved it, but it should be equivalent. Although I'm not sure, it might be more of a hassle because you have to get methyl Grignard. But, you know, that's the way I solved it. The other way is fine. whichever is okay. Hope you guys enjoyed this episode. If you did, please like, subscribe, do anything to support. I would greatly appreciate it, and have a wonderful day.